In this example, we are going to see how will affect plastic insulation and the heat transfer of a spherical ball. So, a 5 millimeter diameter spherical ball at 50 degrees Celsius is covered by a 1 millimeter thick plastic insulation. This is a spherical ball. The diameter is 5 millimeter. It is insulated by a plastic insulation. The thickness of the insulation is 1 millimeter, and also the thermal conductivity of the plastic insulation is 0.13 watt per meter degree Celsius. Then the ball is exposed to a medium at 15 degrees Celsius. The infinity around this ball is 50 degrees Celsius with a combined convection and radiation heat transfer coefficient of 20 watt per meter square degree Celsius. So a medium around this has the convection heat transfer with the surface of this ball, and also we have a radiation heat transfer. The coefficient for this, which is H, is 21 per meter square degree Celsius. Then we should determine if the plastic insulation on the ball, this insulation, will help or hurt heat transfer from the ball. As you know, insulation for the cylindrical shape or spherical shape may increase or decrease heat transfer of that cylindrical body or spherical shell. So let's see how it will affect. As you may know, the important thing here is the critical radius of this insulating material around the sphere. So we should calculate the critical radius for the insulating material. But before that, we should have some assumption as usual. Assumption 1, we have a steady state. It is also can be understood from the question. No change in the temperature inside or outside or in the ball with time. It is one dimensional. The heat transfer is only from the center of the ball to the outside in the R direction. Also, the thermal properties are constant. No change in the K or H. The thermal contact resistance at the interface is negligible, so we don't have any or we can ignore the thermal contact resistance in the interfaces of the ball and insulating material. Also, we know that the thermal conductivity of the plastic around the ball is 0.13 watt per meter degree Celsius. Then we can calculate the critical radius of plastic insulation, which is a spherical one, by this equation. We have this equation for critical radius of a spherical shell. R critical equal to 2K divided by H. 2K, K is the thermal conductivity of the insulating material, divided by H, which was given by the question, is 20. The result of this will be 0.013 meter or 13 millimeter, which is greater than R2. In other words, since the outer radius of the ball with insulation is smaller than the critical radius of insulation, plastic insulation will increase heat transfer from the sphere.